So welcome everybody back to the VM Workshop 2021. Our next presenter is Stefan Raspl from Böblingen, Germany, and he's going to give us an update on Linux. So Stefan, over to you.
Thanks, Bill. So hi, my name is Stefan Raspl and I work for LinuxONE IBM Z and LinuxONE in Böblingen, Germany as a product owner for I/O on LinuxONE Z. And this presentation, we will be taking a look at all of the latest news that you should know around Linux and IBM Z. And this presentation is split into three parts. First, we'll take a look at the current LinuxONE Z distributions, and I'll give you some pointers here. And then we take a look at the IBM Z15 and LinuxONE 3 models, and in particular about the hardware features and how they are exploited with LinuxONE Z. And finally, and that's probably the biggest part, we'll take a look at the latest LinuxONE Z features and packages. So that should give you a nice roundup here. If you have seen this presentation at other instances, you might have noticed that I'm also usually talking about OpenShift for a bit. However, in this event, and since we are a little bit short on time, I decided to skip that, especially since tomorrow there's a slot by Wilhelm Mild, who will be giving you a whole slot about OCP. So let's get started right away. And as usual, we start with the LinuxONE Z distribution. First off, and that question comes up quite often. What was that question? Okay. First off, the question which Linux distribution is supported on which hardware generation comes up quite a bit. And for that purpose, we have a nice matrix which is available online and getting updated once in a while whenever there is some news to update, like a new Linux distribution or new hardware. The respective link is reprinted at the bottom of the page. And it still even lists Red Hat Enterprise Linux 5, which is out of service by now. I think for almost a year, if I'm not totally mistaken. But nonetheless, this one gives you probably even more information than you ever need. Let's take a look at the actual Linux distribution, starting off with SUSE Enterprise Linux. They had a release called SUSE Enterprise Linux Server 15 in 2018, and they are shipping updates on an annual basis. And you can see those updates are shipped pretty much every July. The last one was Service Pack 2, shipped last year. So let's see if they keep that cadence and come up with another one in this year's July or around the time frame. As we'll see, in contrast to some other Linux distributions, like for instance Red Hat, they switch the Linux kernel. However, they do that only for every other release. So the GA version, or well, not even every other one, every third release. So the GA version shipped with Linux kernel 4.12, and SP1 kept that same kernel level, but with SP2, they updated to kernel 5.3. So that's a scheme which we have observed with the previous Linux Enterprise Server 12 release already. And we're used to that, and this certainly gives customers a good portion of value, because there's not only the features for IBM Z that we're constantly backporting and making sure that even if the Linux kernel is not updated, the respective feature code makes it into the next service pack or update level of a respective Linux distribution. But you also get all of the smaller enhancements that the Linux distribution upstream comes up with. So if you're on Linux Enterprise Server 15, you're pretty safe. You can see the service time frames at the bottom, and they have a regular service update time frame, which still lasts to 2028. And if that's not enough, you can purchase an update extension and that goes for another 3 years. They still have 2 other releases in service, which would be SUSE Linux Enterprise Server 11 and 12. However, the 11 release is already out of the regular update service timeframe. So if you're still running that, you probably purchase or should purchase a respective service extension. Otherwise, you should certainly consider to update to a more recently release. If you need more details on the life cycles of SUSE Enterprise Linux, there's a link at the bottom right, and that gives you a nice overview of SUSE's current plans. And since we had some instances recently where customers were running into issues which were already fixed in updates to the respective releases, we added a small remark here at the bottom left, reminding everybody to keep their Linux installations up to date and install the so-called main web updates, which is the ever ongoing stream of updates, which comes on a weekly or monthly basis and keeps your system up to date and fresh, and also provides security fixes and the like. So you'll definitely want to do that. So next up would be Red Hat Enterprise Linux. Their current release is Red Hat Enterprise Linux 8. That came out in 2019, and they are shipping updates every 6 months on a pretty good cadence right now. So their 8.4 release again kept the schedule and was released just last month. And I have updated the charts here respectively with all of the latest features included in there. Otherwise, as before with SUSE, there's service timeframes which extends to the regular service timeframe, and after that you need some service extension. Just like SUSE, they also have 2 other Linux distributions in support, which would be Red Hat Enterprise Linux 6 and 7. And also, just like SUSE, the older one, Red Hat Enterprise Linux 6, is already out of regular service, and you need a service extension for these ones. Now, in contrast to SUSE, Red Hat usually sticks with their initial kernel that they ship with the major release. So Red Hat Enterprise Linux 8 shipped a kernel of 4.18, and that's assumed to be the case till their final update, which according to their webpage, which with the lifecycle details, which I have reprinted at the bottom right, is probably going up until the release 8.10, which is listed on that page. However, Red Hat is very busy in terms of backporting features, and we are certainly contributing backports for our features in support of IBM Z. So don't get fooled too much by this Linux kernel version number. Red Hat is just very selective when it comes to updating their software. And again, Red Hat has what they call the seam stream updates, which are the ongoing updates providing security and service fixes for their releases. And I would again want to point out that you should definitely make it a good practice to keep your systems up to date by installing all of these updates all the time. Finally, there's Canonical's Ubuntu release or Linux distribution. They are on an entirely different model. They have what we call a rolling release model, where they ship an update or a new release every 6 months, always in April and in October. However, every 2 years in April, they ship what they call a long-term support release, or LTS release, as it says here. And they update all components all the time. So they have a new Linux kernel version in each release. They update their toolchain, like the compilers, which was always given as some additional info on this in the previous charts. Each and every package. which certainly gives you early access to the latest and greatest features most of the time. Those releases usually stay in service for roughly 5 years. However, again, there's some service extension possible. So their Ubuntu 16.04 release, which was released in 2016, has already expired. That happened in April this year, just 2 months ago. However, it's good for another 3 years if you get their service extension. And just like with the other distributions, don't forget to apply their updates. They call it SRU updates. So far, so good. So let's move on and let's take a look at IBM Z15. And since these have been released quite a bit of time ago, I'll rather make this a little bit faster because you heard about these probably, I guess, by now. So the IBM Z15 was the first enterprise release which came in the 19-inch industry standard form factor, which certainly helps a lot to place these monsters in your on your raised floor. As far as the actual chip is concerned, we're remaining on the 14 nanometer technology, and the clock speed is also still the same. However, what changed is there's more cores per CP chip, so we're up from 10 to 12, and the cache sizes were also increased. So we doubled the layer 2 cache and also increased the layer 4 cache by 40%. And overall, that's some average number which we found in our measurements. We're seeing a 14% single thread performance improvement, which is certainly a pretty good story for our users so far. It also is capable of installing a maximum of 40 terabytes of memory. I think that's up from 32 previously, and we're up to 190 usable cores from 170 something in the Z14 release. There's also a single frame offering, or sometimes referred to as air-cooled offerings. It's giving you basically the same technology. However, the capacity is a little bit reduced, so you don't get to install as many IFLs and CPs as you could on the multi-frame offerings or water-cooled models, but the raw performance numbers should be still the same. Also, you cannot install as much memory, stuff like that. I/O devices is also a little bit reduced, just because the boxes are not so big anymore. Now, summarizing our IBM Z15 toleration support, and that applies to both the water-cooled and the air-cooled models, you need to make sure you're hitting the right Linux distributions or running the right Linux distributions. Recall the chart that I have shown you at the beginning with the matrix, which was showing you which Linux distribution has support for what hardware level. The catch there was that it was only indicating the major version number. So it would have listed, for instance, Red Enterprise 7.7, Red Enterprise Linux 7 to run on IBM Z15, but not which exact service pack update. And that's the information you get on this chart. And it also extends towards the CVM hypervisor, of course. So prior to upgrading, in case you have a migration project from a Z14 to a Z15, make sure you have these as the minimum levels, whichever applies to your case, installed, and it should be a very smooth experience. Now, let's take a look at the latest features that we provide. Starting off with the IBM Z15 support. So first off, IBM Z15 introduced yet another set of vector instructions, or sometimes also referred to as SMCD instructions. Here's a small snippet how to verify that they are available to you, which of course should be the case on any IBM Z15 release model. And what they bring is yet another set of vector instructions with a little bit of more focus on string-related actions, like for instance searching in a substring or this mem call. And we're taking advantage of all of these instructions at various places. primarily in our compilers. So these instructions would be used to optimize code during the compilation stage, but also in libraries like, for instance, the glibc library. And we also take advantage of these instructions inside the Linux kernel and some selected other projects. We'll see that later on. So there's, for instance, some AI-related projects where we can take advantage of these instructions beyond what, for instance, the compiler would automatically do here, and just call the respective instructions directly in case they are available on the hardware platform we're currently running on. Deflate is certainly one of the most impressive features. What it does is it's providing compression in hardware, which is the equivalent to the gzip compression algorithm as found in Linux at compression level 1, which gives you the fastest compression in software already. However, if you do that in hardware now, we get awesome boosts, as you can see here. We have somewhere between 24 times faster compression performance up to more than 40 times faster. And that's just some of the numbers we have. So that's a massive increase in performance here. And it's really astonishing if you apply this to, for instance, a huge dump which you're about to send over somewhere. Usually they are so big, and compression doesn't give you so much of an edge because binary data doesn't compress so good that it's not really worthwhile, and you're likely to skip compressing because you just take forever to compress it. But if you run it through our hardware compression, that goes so fast, it's you almost doubt whether it has actually happened. So at first, this compression had to be enabled in the Linux distributions because we're only applying it in case users were using the first compression level with gzip or clib or whatever you were using to compress. However, starting with these Linux distributions listed here, we changed that and we made hardware compression the default now. So if you're running any of these Linux distributions or later releases, we will be using the deflate hardware acceleration per default if it's available. Otherwise, Java is also worth mentioning here. So if you're running a sufficiently high Java runtime, that will also take available of the deflate hardware feature. And otherwise, if you want to know a lot more details, there's a pretty good blog entry which I referenced here at the bottom of the page in this link. CPACF is a crypto instruction which accelerates some of the crypto operations that we need, and this is coming in its 9th expression, and this time it's focusing on elliptic curve cryptography. And what it accelerates is message authentication, generation of curve keys, and scalar multiplication, which is used when applying elliptic curve cryptography. So how to exploit that? Actually, support is built into SSL and the TLS protocol, and we have enabled OpenSSL respectively. So if you're running on an IBM Z15 and you have CPACF available to you, that will just nicely speed up your performance. And speaking of performance, there's some performance numbers we have just to give you an idea. Again, since we're doing it in hardware, we're doing an awful lot better than in software. So key exchange operations would be 20 times faster on average, or up to 20 times faster. Signing operations up to 30 times, and verification operations up to 10 times, which is all pretty impressive numbers here. Secure boot for SCSI is a feature which ties into our pervasive encryption story. So what it does is it's making sure that the code which is loaded during the IPL is actually what the Linux distributor provided to you. So you're protecting yourself against somebody trying to get you to boot a corrupted or tempered Linux kernel image, which could be doing any kind of harm here. And what we're doing is we're basically verifying the so-called chain of trust. So we're making sure that each component involved in the boot process has full integrity and is signed by an accepted authority. And in terms of the Linux distributions, that applies in particular to Red Hat, SUSE, and Canonical Linux distributions. However, this requires you to make sure that SIPL is in place accordingly. The Linux distributor, of course, has to do his part and make sure that his image is signed accordingly so it can be verified by us. And you need to make sure you switch over to the secure boot on the HMC, because per default it is not enabled for the partitions. Also, it needs a firmware update, by the way, which I guess at this point probably everybody should have. You can verify in your Linux distribution whether you're running in a secure environment and whether it is available to begin with these two CDFS attributes. And otherwise, and that holds true for the rest of the presentation, on the upper right you see the respective Linux distributions which ship the respective support here. So speaking of storage devices, another thing we'd like to highlight would be NVMe drives. So in this case, and this is the first for IBM Z, we're not actually shipping NVMe devices itself, but what we're shipping is an adapter card, which is a carrier card that can be used for standardized NVMe devices. So you can plug the respective device inside the card and push it into the I/O drawer respectively and make use of it. Now, why would you want to use NVMe drives? For one, you might already have heard about it, that NVMe is low cost, but also very low latency and high throughput storage. So the performance characteristics are certainly very, very good. But what's also very interesting to us is that this, for the first time, provides you storage on your IBM Z box. So you do not need to connect some external storage through a storage area network, but you can directly attach it to your Linux partition running on the IBM Z or LinuxONE. So you do not need any additional cabling or switches or whatever. So whether you use it for some local storage to host your images, or whether you want to just use it as some additional storage device for extremely fast data access, is up to you. But we're making all of that possible. So support for regular use, as I would say, of the NVMe devices is available in a wide array of Linux distributions as listed here. But there's more if you want IPL support, which means you could install a Linux distribution on such an NVMe device. You could actually boot from it, so you could make it your root or at least your boot partition. And that certainly needs a different set of Linux distributions as a prerequisite, and that makes that possible. Like I said, storing data is certainly an option here, so you could use it for swap, for instance. So that would give you very fast swap devices, and certainly improve your performance in Linux in case you are a little bit short on memory and have to swap. And otherwise, any other distribution, any other mount point or storage device would also work here. As for operating, there's really nothing different between x86 Linux and Linux on IBM Z. So you just use it as a regular PCI device, and commands like list block just work out of the box. SMCD version 2 is the latest continuation of our SMCD story. And this time around, we made quite a big leap in terms of usability and eliminating one of the most dreaded prerequisites which we previously had. So, as you can see on the drawing on the right-hand side, previously with SMCD version 1, we had a limitation where both peers participating in SMCD had to be in the same IP subnet. So peer A and peer B could be in the same IP subnet, but peer C would be unreachable because it's behind a router in a different IP subnet. Now with SMCD version 2, that changes. So now that peer C becomes reachable. So basically you do not need to care about your network topology anymore. Whatever or wherever your peer is located, as long as at the end of the day it's hosted on the same box as SMCD is, you can connect to it, and SMCD will then accelerate your TCP traffic drastically, giving you a lot faster, higher throughput, lower latency, and at the same time reduce your CPU consumption. The other thing is that we improved the configuration. So previously you had to mess around with so-called PNet IDs. I'm not even going to reiterate what exactly that meant, but if you have configured SMCD version 1, you had to assign these PNet IDs to certain interfaces and devices and make sure they match and everything. But with SMCD version 2, that's no longer the case. We just did away entirely with it. So you just have to make sure your ISM devices are present and you're pretty much set. It requires a C15 or LinuxONE 3, and we're just rolling it out so far. It's available in the latest releases by Ubuntu and Red Hat Enterprise Linux. Speaking of SMC, we also extended the SMC-R support a bit. So what we're previously missing was so-called link group support. That's basically high availability for SMC-R. Now, to remind you, SMC-R was using Rocky Express adapters for connecting a peer using RDMA traffic. And previously, while COS was able to take advantage of multiple Rocky Express adapters and possibly failing over to a still working one in case one went down. With Linux that didn't work, we only could take advantage of a single port. And with link group support, this is being changed. So now we are able to switch failover in case you have two Rocky Express adapters available for or configured for SMC-R. The downside is that the reference architecture, and this is very important, currently requires you to have two Rocky Express adapters and two OSAs for regular IP connectivity. We're looking into how to improve that, but that will take a while. Otherwise, we also did some updates for the SMC tools, so we have some additional information like more conveniently listing the capabilities of your current platform, so you can easily see which SMCD versions are supported and what your hardware capabilities are and if they match. And also we have a new tool called SMC Check, which is hopefully improving your configuration experience, because that's a very convenient way to verify whether SMCD is set up correctly, and if not, what exactly is the problem with your setup. Finally, HyperSockets Converged interface. So this is another networking technology, and what it does is it's converging a regular NIC along with a virtual NIC, which is basically representing a HyperSockets interface, into what we call an HSCI interface, which is short for HyperSockets Converged interface. And what it does is, I should show this here over at the Linux box actually. What it does is, it prefers HyperSockets over the NIC, which could be either a Rocky Express adapter or an OSA Express adapter whenever the peer is reachable. So in this example here, this Linux #1 here, I didn't draw any Ethernet connectivity here, not to make this too busy of a drawing, but you can assume it's probably also tapping into the external LAN. So if Linux 2 would talk to Linux 1, it's probably going over the NIC, because Linux 1 is not reachable through the HyperSockets interface. But if there's, for instance, a COS instance running somewhere and also has HSCI configured, now we realize, okay, this guy is reachable through HyperSockets, so we take advantage of HyperSockets because that gives us a lot lower latency. So it's basically eliminating some of the complexities. You do not need an additional IP subnet anymore. You can conveniently converge HyperSockets and the external LAN into a single big one. If you're familiar with, or intimately familiar with CVM, I guess you all are familiar with CVM anyway. If you're intimately familiar with the CVM vSwitch, there's the functionality called the bridge port support, and this is basically the equivalent in Linux for LPARs. Again, that requires IBM Z-15, that's what you need to be aware of, and we're shipping a respective update, so here's a small snippet of how to set it up, and it's of course compatible especially to COS. So, back to storage. I should have put this earlier in the charts. So this is a feature which has been out there for a couple of months, for a little while, but we're continuously updating it. This is called CDFS. It is part of the S390 tools, and what it does is it provides access, currently in read-only, to COS data sets on a DASD. So what are we talking about? Here's a small picture to give you an idea. So what you have is you have a COS application which writes data to a DASD, and now the price question is, what's the fastest and most efficient way to access that data on that DASD from Linux? And what in a lot of cases customers do, or were actually forced to do so far, was to set up an FTP server on COS and connect to it from Linux. And that means you're sending all the data from the storage device over COS to Linux over a networking device, which means it burns a lot of cycles. And that costs you, well, CPU cycles, which is costing you, also in a monetary way. Now with CDFS, what's possible now is you can mount that DASD inside Linux using the CDFS device driver. It's actually a user space file system device driver. And you can access it directly in Linux. And that means COS does not spend any cycles transferring the data. It's actually, you could detach that disk from COS and just use it in Linux on its own. And that's much more efficient because you do not need to invoke a networking connection anymore, and you do not have to spend any cycles in COS. So that's been around for a while, and we're constantly updating it. So the latest improvements were, for one, we have been increasing the robustness a bit. So to prevent concurrent accesses, that's handled a lot better now. Starting with these Linux releases listed here, we have what we call coordinated read access, and finally, and that just very recently went upstream, is what we call transparent data set conversion, because if you have text files on the DASD here, they're obviously in EBCDIC. Now Linux is ASCII, and that means the conversion needs to happen. You can do this in Linux, but it's a little bit tedious, so we built that functionality into CDFS, and you can set up config files which specify, for instance, files by a pattern or by an absolute file path, which should be converted from EBCDIC to ASCII. Here's a small example down here, just to give you an idea of what we're talking about, how to set it up. Very interesting. We're continuing to work on this, so there might be more features coming in the future. Now other packages, and now we're getting into away from the features and more into packages that we're either improving or providing. So these are all IBM provided packages listed on this page. S390 tools, latest release was in February, and that shipped HSCI, that was a user space tool required for managing HyperSockets converged interface. We talked about that before. OpenCryptoKey had an update in October last year. It's been a while. There's a change list here. QClib had an update this year, which added two new commands due to requests from our users on the public mailing list. I think that even was on the CVM mailing list, actually. And what we did was, for one, the chypeinfo, which is a command which prints the virtualization stack you're running on. So for instance, if you're in a CVM guest, it will give you a brief output indicating where you're running actually. You know, is CVM, for instance, second level hypervisor? Are you in LPAR, or are you running somewhere else? All of that information is reprinted here, and it's also giving you some coarse counts of CPUs that are available in the different layers here. And we also threw in another command, which is called cname, which gives you the current hardware generation we are running on, because that's some piece of information which is not trivial to figure out. And if you're remotely connected to a machine, it might not be obvious to you what hardware generation you're looking at and whether certain features are available to you or not. And finally, the SMC tools, but I've talked about that before. So compilers, and that's just for completeness, we continue to focus our development efforts on both GCC and the LLVM compilers. IBM Z-15 support is readily available in both of these, and that is pretty much about it I want to say on this page. There's some other libraries and debuggers we're supporting for our hardware platform. The GNU C library I talked about previously, and as I mentioned there already, we're, for instance, looking into optimizing it for IBM Z-15 specific features. The GNU debugger GDB has support for the Z-15 instruction set. Wellgrind is does not yet have IBM Z-15 support. However, for practical purposes, for our users, that's not much of a problem, because all of the distributions out there till today just build code for the instruction set of the IBM Z-14, which is supported here, so no problem here at all. And when it comes to profiling, there's the universally usable perf tool, which we continue to support with IBM Z-15 support. If you want to take advantage of that, here's a small snippet indicating your required settings in the HMC to make hardware sampling available, but that's about it. There's other libraries which received IBM Z optimizations, and LinuxONE, of course. There's two algebra libraries, which are both OpenBLAS and libAtlas. Both are being used for a couple of frameworks, like, for instance, NumPy on R and Octave. And we just started to optimize these, so we don't have, and we're going back from the past, basically. So we start with C13 optimizations, and we're going forward from that. So currently we have updated those with C14 optimizations. Eigen is another package which comes as source only, so you need to build it yourself on your Linux distribution. That's why we don't list any Linux distributions over here. And we started to optimize this for IBM Z-15. So far we only have added some alignment hints, and we might see some more optimizations here in the future. The very latest edition was Anaconda, which is a pretty popular data science platform. And that again is like a distribution within a distribution, which means you install the Anaconda framework, and that allows you to install further AI tools and frameworks. And we worked with the Anaconda team on this one, so it's been becoming available on these distributions. And again, that's minimum distribution levels. So if I'm writing Red Hat 7 over here, that also means Red Hat 8 is also included and supported. And likewise for SUSE with SUSE 15. So finally, some miscellaneous things. First off, I'm not sure how widespread that is, but we're running some blogs, especially one on Linux on IBM Z and the containers. So that's certainly something you might want to check out from time to time. Whenever there's a new Linux distribution, we at least give you some head up there. And also if there's some bigger new features or presentations which are freely available, we will make sure we post something in there. So that's certainly the best way to stay up to date with what the Linux development team is up to. And finally, the references. Well, there's IBM documentation by now, so all of our materials are to be found there. I already mentioned the webcasts, which are announced also in the in our blog externally. Otherwise, Stefan is doing a great job at inviting folks, but if you just want to get started, this is certainly a good place to visit this webpage, because that has recordings of all of the previous webcasts that we did. And I already mentioned the blogs here. So that's pretty much what I had. So I'd be open for questions if there are any.
So folks, if you have any questions for Stefan, you can either put them in the chat and I'll relay them, or if you want to take yourself off mute and ask them, that's fine as well.
Yeah, I have technical troubles with the chat, but I'll get that sorted out, and I'll certainly answer those later on.
Stefan, question on CDFS. That's, you mentioned part of SUSE Linux by default, so that's not like a chargeable feature or anything. It's just available for use right within Linux. Is that correct?
Absolutely. That's part of the S390 tools package, which is available in pretty much every Linux distribution. And you just need to make sure that I would have to go back a little bit. Oh, there it was, right? So these are the Linux distribution levels, which is a minimum basically, and these two distribution levels receive the very latest update here, the coordinated reaccess.
Excellent, thank you.
Welcome.
Okay, Stefan, I don't see any questions in the chat. So with that, we'll wrap this up. Thank you very much, Stefan. Hope to see you next year at the face-to-face event.
Oh, I hope so much as well. Yep. Looking forward.